Hello, Accelerated Math 7-8 students. We are starting our 8th video, comparing tape diagram solutions to algebraic solutions. We are also, just so that you know, getting down to the last 3 lessons, and after the third of the last 3 lessons, then we are finished with this module. So we're moving along quite well. So again, comparing tape diagrams to solutions, comparing tape diagram solutions to algebraic solutions, finding that on page 23. So I'm turning there. Here is page 23. Comparing tape diagram solutions to algebraic solutions. So basically this lesson is all about what the title says. We are actually going to learn how to use a tape diagram as a visual representative to help you understanding how to complete algebraic solutions. It's kind of cool. Our goal today, we will learn how to use tape diagrams to solve equations. The question that I want you to be thinking about is, can a tape diagram help you understand how to solve the equation? Now, just as a quick review to remind you of some vocabulary terminology that you need to know, remember that an expression is a math sentence built of numbers and symbols. The major thing to remember on this is that expressions have no equal sign. An example of this would be 1/2 times the quantity x plus 8, or another example could be 25 minus x. Those are considered expressions because, as you notice, there is no equal sign. An equation, on the other hand, is a math sentence built of numbers and symbols and an equal sign. So the equal sign is present in an equation. How the example from above changed was 1/2 times the quantity of x plus 8 equals 28, or 25 minus x equals 15. So both of those are examples of equations. Okay, so today what we're going to do is we're going to work with these problems right here, but we're going to use tape diagrams as solutions to help us figure them out. So the tape diagram is a model used to see how to solve an equation. And so I'm actually going to show you how to do this with these 2 equations, and then you're going to practice it in class tomorrow. So the first one, let's try, is we'll go ahead and do this one, and then we'll backtrack and we'll try to do this one up here. So we have 5 times the quantity of x plus 2 equals 40. So we do know 5 times the quantity x plus 2 equals 40. So first of all, the way we use tape diagrams to figure this kind of stuff out is we have to figure out what we have represented in our equation so we know what we're doing. First of all, we have x plus 2, okay? And we notice that x plus 2 is happening 5 times. So this number right here in this problem is telling you the number of sections of tape. So I'm going to draw a tape. Okay, it's been a long time since we've done tape diagrams, I know, but it'll come back to you. And we're going to say that's 1 section, 2 sections, 3 sections, 4 sections, and 5 sections. Okay, and the second thing we need to know is this whole thing from the start to the finish is equal to 40. And the reason we know that it's equal to 40 is because it says 5 times the quantity of x plus 2 equals 40. So we know this whole tape diagram equals 40. Our job now is to put what goes in each section. Well, the way we can figure that out is we have 5 of the same things. And the same things happen to be x plus 2. So what goes in each section is x plus 2. X plus 2, x plus 2, x plus 2, x plus 2, and x plus 2. Okay? So now we have the tape diagram. We know that it's set up to equal 40, and now it's just a matter of combining like terms to figure it out. So there's actually 2 different ways you could do this. You could take, okay, what's in the section, and we know that it happened 5 times, so you're going to use the distributive property, and you're going to say, since it happened 5 times, then I know that I have 5 x's, because 5 times x equals 5x, plus 5 times 2, which equals 10. And then we know that 5x plus 10 is all equal to 40. So that's one way to solve it. Or another way to solve it would be to do x plus 2 plus x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. And then, because remember, tape diagrams are added together, we're going to add them all together. So 2, 4, 6, 8, 10 plus 1, 2, 3, 4, 5 x's. And you will notice that either way, you end up with the exact same equation. Okay? So you can do it either way. All right? The tape diagram just gives us a picture of what it's supposed to look like. So then the next step of figuring out, because what you're trying to do is you're trying to solve for x, you're trying to figure it out, is we do what we learned last year, is you're trying to get x by itself, so we're breaking it apart. Right now we see the first thing that's happening to x, okay, is we're going to do our build and undo chart. I can't remember if I taught you this last year or not, but we'll go. So the first question is, what is the variable that you see in either equation, because they're exactly the same? That's right, an x. Okay, now, thinking mathematical operations, tell me what operation closest to x is happening first. So here's x, so what is the mathematical operation that's taking place right here? If you said multiply by 5, you are correct. So that's the first thing that happened to x. Then, the next step away from that would be what? What is happening right here? You are adding 10. Okay, so that's how they figured out how to build that equation. So our job is to unbuild it so we can solve for x. So unbuilding means you do the opposite in the opposite order. So we're going to work our way back up because we're going in the opposite order. So what is the opposite of plus 10? Subtract 10, good. What is the opposite of multiply by 5? Divide by 5. And when you do that, you're left with your x answer. Okay, so now we're going to try it. It doesn't matter because, look, these equations are exactly the same. But what I'm going to do is I'm going to write it one more time so that I can show you how to use the build and undo chart to do this. So on the undo side, that's what we're actually doing. It was built when it was written. We're performing the undo side. So the first thing on the undo side to do says to subtract 10. So I'm going to subtract 10 from both sides, knowing that when I subtract 10 from this side, 10 minus 10 creates a 0 pair. So that means it's gone. It's now a 0. What is 5x plus 0? It's still 5x. Equals, what is 40 minus 10? 30. Because remember that rule. What you do to one side of the equation, you have to do to the other to keep it balanced. So now we get to put a little check mark on the undo side. We now have to divide by 5 because we're trying to get x by itself. So I'm going to divide this side by 5. What you do to one side, you have to do to the other. So 5 divided by 5 is 1 times x, which gives me x. And then we have 30 divided by 5 equals 6. And what we have to do is bring them all down. So now, if we did it right, this should be able to be plugged into our tape, and we can solve for it. So let's try it. Everywhere you see an x, instead of an x, it needs to be a 6. So now let's do our tape again. And this time, we're going to substitute in 6 for the x. So 6 plus 2 is 8. 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 What is 8 plus 8 plus 8 plus 8 plus 8? Does it equal 40? And the answer is correct. So now you know how to use the tape diagram to help you solve an algebraic problem. Okay? Awesome. All right, so now let's try the next one. Ooh, it's a little trickier. It says 1/2 times the quantity x plus 8 equals 28. Okay? So how would we draw a tape diagram to represent that? Wow, that's kind of interesting. So basically, a tape diagram to represent this section right here would be x plus 8. And we don't even have a full one of those. What we're doing is we're taking this tape and we're cutting it in half. So basically, you're taking x plus 8, and you're splitting it in half, okay? So if we cut that in half, it's kind of hard to draw that. I guess we could either go this way or let's do it this way, okay? So what you have to ask yourself is, what is half of x? Well, exactly that, 1/2 x. Plus, what's half of 8? 4, and all of that is supposed to equal 28. Okay, well, we can keep trying. So now we're going to do our build and undo chart. How was it built? Remember, you have to start with what is closest to the variable. What is the variable? The variable is x. What is the mathematical operation that took place first? You multiplied by 1/2. Yeah? What was the next step? We added 4. So now we're going to undo it. So what is the opposite of add 4? Subtract 4. Good. What is the opposite of multiply by 1/2? Divide by the 1/2, which is the same thing as what? Multiplying by the reciprocal. What is the reciprocal? Times by 2. Good. And then you're left with x. Okay, so let's try it. First thing we do is we subtract 4 from both sides. Okay, subtract 4 from both sides. So 4 minus 4 creates a 0 pair. 0, 0, 0. Does everybody see the 0 there? 1/2 x plus 0 leaves me 1/2 x equals, what is 28 minus 4? 24. Okay, so now that's done. Put a check. The next thing says multiply both sides by 2. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2, because that's what it says to do. Well, 2 times 1 is 2. 1 times 2 is 2. X, what is 2 divided by 2? 1. X. 1 times x is x. Did you see that without it falling off the page? Let me do it again. 2 times 1/2 equals 2 halves. 2 divided by 2 equals 1. 1 times x equals x. Does everybody see where I am? Okay, nice. So what is 24 times 2? 48. Keep going, 48. Keep going, x equals 48. So now we should be able to plug 48 back into this, and it should make sense. So let's see. If we put a 48 there, 48 plus 8, and then we cut that in half, we should get a 28. So let's say, what is 48 plus 8? 48 plus 8 is 56. And then 56 cut in half should equal 28. Let's see if it works. 56 divided by 2 equals 2, 6. Ha ha! It worked. Does everybody see that? Okay, so this whole thing, remember, I forgot to put this part in there, was supposed to be equal to 28. So we substitute 48 plus 8 equals 56. 56 cut in half, cut in half. That section equals 28, and we found it. Okay? Do you see how the tape diagram can help you? All right, so I will give you some more practice problems with this in class, and hopefully you will find as much value in using the tape diagrams as I did, because it's kind of fun. It's bringing stuff back from 6th grade, which was kind of fun. All right, that's it, my dears. Okay, very quickly, how can the tape diagram help you understand how to solve the equation? I need you to answer that question for me by tomorrow, and I'll see you then. All right, have a good one. Bye.